Hello, and welcome to TrainSignal. I'm Don Jones, and this is the Database Normalization lesson in the Database Administration Fundamentals course. In this lesson, we'll be talking about something called database normalization. Now, it's a somewhat complex topic, so we'll break it down into the 5 normal forms: first normal form, second normal form, third normal form, and we'll briefly discuss fourth and fifth normal form. We'll also talk briefly about the concept of denormalization. The main purpose of normalization is to reduce data storage and to reduce data redundancy by making sure that any given piece of data is stored only one time. There are 5 techniques involved in fully normalizing a database design, although many people consider the first 3 forms to be sufficient and practical for most purposes. The 5 normal forms are shortened as 1NF, 2NF for first normal form, second normal form, and so forth. Now, these are best seen in examples, so in addition to defining them, we'll also cover an example for at least the first 3. We'll start with first normal form: eliminate repeating groups. This simply means that no records in the table should be duplicates of each other. And you should also have no multi-valued attributes, like storing multiple phone numbers in a single column. All entries within a single column must also be of the same data type, meaning that if you decide to populate a particular column with dates, then every entry must be a date. SQL Server actually makes that last bit pretty easy to achieve, because once you define a data type for a column, SQL Server enforces that data type automatically. For example, here we have a simple table called customers with 2 columns. You can see that we have not done a good job of meeting first normal form. First of all, the customer Don Jones is in there twice. Now, we don't know if that's the same person or 2 different people with the same name. We've also got 2 phone numbers for Don and Stacy, and that definitely breaks first normal form. The solution would be to break these into 2 tables. Here we have a customers table, and we've assigned a unique ID number to each of our customers. Looks like Don Jones was the same person. Now we have a customer phones table as well, and we use that customer ID to link it or relate it back to the customers table while providing a separate row for each customer's phone number. Now, one of the rules of normalization is that you have to start with first normal form. Second normal form assumes that you've already reached first normal form. Third normal form assumes that you've already reached first and second, so they build upon one another, which is one of the reasons we're discussing them in this order. So second normal form says to eliminate redundant data. Make sure that each column describes or has something to do with the entity that the row represents. This is a big part of why in relational database management systems, a row is often referred to as an entity. It represents a person or a product or an address or something else, and each column in the row should contribute to that description of the entity. You'll often achieve this at the same time that you're working on first normal form, because these 2 are very conceptually similar. In our first normal form example, the phone number did not describe the person. They're completely separate. That person could change that phone number very easily, and that person could move out of the house and someone else could inherit the phone number. So the person and the phone number are separable. So moving the phone numbers to their own table also achieved second normal form. Third normal form tells us that we should eliminate non-dependent columns. This is also referred to as eliminating transient dependencies, and again, conceptually, this can be very similar to second normal form. With second normal form, you eliminate cases where value 1, some value, is not dependent upon the table's primary key, which we were using as the person's name. With third normal form, we eliminate cases where value 2 is dependent upon value 1, but value 1 is still not dependent upon the table's primary key. So you can't really get to third normal form unless you've already met first and second normal form. Again, all the forms of normalization assume that you've met all the prior forms of normalization. So here's an example. We have a table for stores. This might list retail store locations. We have a location name, Las Vegas and Denver. Each store has a phone number. Each store has a manager. And each manager has a hire date. And this does not meet third normal form because the manager hire date is actually dependent upon the manager. And that manager is and always will have been hired on that particular date. The manager's hire date really has nothing to do with the store. In addition, the manager itself has nothing to do with the store. The manager Chris and Eloise do not help describe the store's location. We could easily change managers, and so those two need to be separated. The solution would be to perhaps create a store managers table, which I've shown on the bottom. Now, I have not yet gone back to the stores table, which is on the top, and removed the manager and manager hire date. This is sort of the interim step of copying that data off to a new table. Now the manager hire date can be dependent upon the manager and nothing else in the table. The two are still linked. Because a manager is assigned to a location, I'm linking them using the store location as a primary key. In other words, the store's location uniquely identifies the store, and so I can use that as a linking or relationship attribute in the store managers table. So I've used the word primary keys a couple of times, and I guess I should explain what they are. A primary key is a specific value that uniquely identifies an entity. In many cases, this is going to be a made-up unique ID number, something that SQL Server just sequentially assigns as you create new rows. However, in the previous example, it could be something else, like a city name or a person's name. That gets to be tough, though, because people in cities can obviously share names. There's more than one city named Las Vegas, for example, and simply using Las Vegas isn't really going to guarantee that that's a unique value. You could also have composite keys, which consist of multiple values or multiple columns that, taken together, are unique. There might be two cities named Las Vegas, but there's only one city named Las Vegas, Nevada. So if we had a city column and a state column taken together as a composite key, those could become a primary key, uniquely identifying a particular entity. Even in that case, if we had a stores table, it's unlikely we would want to use that composite key as our primary key. After all, what if we opened up a second store in Las Vegas, Nevada? So that's why you tend to just use made-up unique ID numbers as your primary keys. You just assign them as you go. You let SQL Server automatically create new sequential values, and you just use that as your primary key. So getting back to normalization, we're on to fourth normal form, which states that there can be no independent multiple relationships. This exists when two columns are brought together to form a primary key, so a composite key like we were just talking about, along with a third column. If the two key columns don't really uniquely identify the entity without the presence of the third column, then you've violated the fourth normal form. And this really gets back to that store example I gave you. If we had a table with a city, a state column, and it was Las Vegas, Nevada, and we opened up two stores, then we would have to have a third column that was perhaps the store number. That third column is also required to uniquely identify the store. Yet if it's not part of the composite primary key, then we have violated fourth normal form. Fifth normal form tells us to isolate semantically related relationships, and this generally involves relationships with three or more entities involved. This is a fairly complex concept in terms of design, and a detailed description is beyond the scope of this course. You need to know that fifth normal form exists. You kind of need to know that it involves isolating semantically related relationships, but that's about all you need to know for now. There are some other benefits of normalization beyond reducing redundancy and reducing data storage, and one of those is reducing locking contention. Locks happen when multiple different users try to update the same data at the same time. With normalization, you reduce the odds of that happening because data has been separated into different tables. Locking generally occurs at a row level, which means if I have one gigantic row that has tons of data in it, anybody who wants to get in there and update a name or a phone number or an address, They all have to lock that entire row in order to make that change. And in a very busy environment, where you've got a lot of users all hitting the same database, there's a higher likelihood that they're all going to try and lock that same row, which means they essentially have to wait in line. By normalizing the database design and moving that information to separate tables, I can allow different people to update different bits of data, a name, a phone number, an address, without having them all locking the same table row. Normalization also improves future extensibility by keeping your data more modular, so that you can change database schema changes to grow that design over time and have a less severe impact on the overall application system. Now, normalization does have a cost. Taken too far, normalization can lead to reduced performance because SQL Server has to repeatedly join large numbers of tables, which is a performance hit. I mean, from a performance standpoint, we really do want to stick everything into a single row. That way SQL Server can read it all out quickly. There are downsides that we just talked about to that, and so normalization really becomes a balancing act. And in some cases, denormalization is desirable. This is when we deliberately break certain normalization rules in pursuit of improved performance or reduced complexity. For example, in this design, I have an addresses table shown at the bottom of the screen. It's designed to sort of represent a street address, and you'll notice that 3 of these columns draw their values from other tables. I call these lookup tables. Pre-street contains values north, south, and east. So my first address looks like it's going to be North 345 Main, and the type is street, and the post street is east. So it's North 345 Main Street East. That's a long address, but it's the type of thing that happens. In order to look up this address, SQL Server has to really join all 4 of these tables together. Now, joining 4 tables isn't a massive performance hit for SQL Server, and I don't want to give you the impression that that would hurt SQL in any way. This is an example. If you were to blow this out to 12, 13, 14, 15 tables, then you would start to get some performance impact. So one way to address this is to deliberately break some of the rules of normalization. And I've done that here. I'm still providing the lookup tables. I still have my pre-street, type, and post-street tables, but I've no longer related those to the addresses table. I'm only including those so a client application can quickly query those and determine what the allowable values are. So when my client application asks a user to enter a new address, it's going to query the type table. And it's going to say, hey, you can only use avenue, street, or road. You can't use anything else. We're not allowing those values. It might even present that information in a drop-down list box so that someone cannot accidentally enter an invalid type of street. However, when I store the data in my addresses table, I'm not linking back to those lookup tables. I'm copying the data. So the addresses table actually says North 345 Main Street East. I'm no longer required to join these tables in order to get all of those values. This isn't a bad thing to do. After all, how often do you think the terms north, south, east, and west are going to change? Probably not all that often. So it's pretty easy to include those in a lookup table, and there's not a huge downside from a performance or storage standpoint of denormalizing those values into the addresses table, and it makes the lookup of that data a lot faster because SQL Server doesn't have to join all of those tables together every single time we want to grab out an address. This lesson has been your crash course in database normalization. We've covered first normal form, second normal form, and third normal form. And keep in mind that a lot of designers consider those to be the minimum mandatory requirement. If you've gone that far, then you've probably done a good enough job. However, there is also fourth and fifth normal form. And although you might have met all the rules of normalization, you might want to back off a bit and use denormalization to meet specific performance or complexity goals in your database.